So for the remainder of Chapter 7, we're going to spend a lot of time trying to prove things. In some cases, we're going to be proving things that we may already know to be true. But in proof, what we try to do is start with something that we know to be true, and then we try to extend that idea to something new. So we talked about proof a couple of weeks ago. I tried to outline it as what do we know, and then what can we say as a result. And so as we work through these proofs, we're going to start off with what do we know, and then try to prove. So they're doing a nice job in these problems, kind of outlining how to set the proof up, and then I'll show you a setup, and then you can use that as a kind of a guide for the proof. So we're going to be exploring a rhombus to begin with, and so going back to Chapter 1, we have a definition. Quite often, with definitions, students want to add in things that are not there, and as a result, proof can be a little more challenging than it's intended. So make sure that you know your textbook's definition for rhombus, because there are lots of textbooks, and you have the internet as well, and so you could get a definition for a rhombus that it does not align with your textbook, and so therefore what they're asking you to prove may not make a lot of sense based on the definition you're looking at. So in our proof, I'm going to go ahead and show you what I have. So this is kind of the outline of the proof. So they're asking you to actually try to prove the triangles to be congruent. Quite often in proof, we do that. Because if I can prove the triangles are congruent using 3 pieces of information, then I can also say that 3 other sets of information must also be true. So proof generally, especially with quadrilaterals, we do a lot of triangle congruency proofs. So once you have this much of the proof in your notes, then turn the video back on. So in trying to prove something that we don't already know for a shape, usually we're thinking about angles and side lengths. So with a rhombus, the definition of a rhombus is a quadrilateral with 4 equal sides. And that's it. Everything else about a rhombus, at least for your textbook, we're going to prove. So she suggested that you put in line 7 PR, try to prove the triangles are congruent. If you do that, then what other things do you think we can prove? So I want you to think about that, turn the video back on when you're ready to continue. So as we work through this proof, you may have come up with some ideas that we're not going to actually prove today, but maybe we'll come back and prove it another time. So what I'd like you to do is put in the information that we could use from the diagram to say these 2 triangles are congruent. Make sure that you indicate not only the statement but also the reason, and then make sure here you're also indicating the reason we can say these triangles are congruent. When you're finished, turn the video back on. So in your proof, yours may look a little different than mine. I chose to do a triangle rotation around the midpoint of PR, so that this side and its opposite side are congruent, as well as these 2 sides. Since it is a rhombus and all 4 sides are congruent, we could thought of PR as a line of reflection and made PS and PQ the same, and SR and QR the same. Either way, the triangles are going to be congruent. If you don't have yours done the way I have mine, and you want the information to look the same, I would suggest making adjustments. But if you did a reflection, the only difference will be our choice of letters. So we do have two sets of congruent sides, and then PR is congruence itself, and that's called the reflexive property. I introduced that term a few weeks back in Chapter 6. Basically, reflexive property is an algebra property that says that something is basically congruent or equal to itself. So the 2 triangles are congruent by side, side, side. So from here, we can say that we have angles that are congruent, and we should have 3 sets of angles that are congruent. And the question is, if I have congruent angles because the triangles are congruent, what else will I be able to say? How does angles help me say something about the rhombus that isn't part of the definition, which again is a quadrilateral with 4 equal sides? Think about that. If your ideas of what you thought were true did not include the angles, think about how angles might be helpful here in proving something new. So hopefully you thought about the fact that if I have congruent angles, that hopefully that I can arrange the angles in such a way that I can also say I have parallel sides. So again, as I mentioned, they're quite often in proof, we're going to be actually proving things that we already know to be true, or you've known to be true for a long time. But the idea of proof is to take something that we believe to be true or know to be true and actually show that it really is true in all cases. So if I would let this angle here be one of the congruent angles, and if I want to prove that, let's say, this segment and this segment are parallel, then I would want to use this pair of angles. If you're going the other direction, then what you're going to end up with is having these two angles congruent, and we're not going to be able to prove the lines parallel. So sometimes in a proof, you may find that you go in one direction and you find that, okay, this pair of sides are congruent, but I could choose a different set of sides and end up getting something to add on to my proof, such as parallel lines for this one. So if you went with the reflection approach, then you're not going to be able to prove lines are parallel because you're not going to have those alternate interior angles. So this pair of angles are going to be congruent as corresponding angles, and this pair of angles here will be congruent. The corresponding angles, and then this angle here and this angle here will be congruent. So all three pairs of angles can be used to prove something. So we have actually a pair of opposite angles. We can actually prove that the opposite angles of a rhombus are the same. And because we have alternate angles congruent, we could also say we have parallel lines. So to continue the proof, it would look something like this. We have, we can say, a pair of angles that will help me prove that these lines are parallel, and then I got that third pair of angles as well. So if you go ahead and continue the proof, put in the angles in the right place so we can be able to say that these segments are really parallel. And then we'll talk about the justification for these three loops. Turn the video back on when you're ready. So these two segments here, the PS and the QR, we can say they're parallel if we're going to use the right angles, and we can say that PQ and SR, those segments would be parallel if I use the blue angles, and then the third pair of angles, the green ones. So the reason these angles are congruent is because the triangles are congruent. And so the symbolism we use is CP-CTC, which means the corresponding parts of the congruent triangles. So these are the corresponding parts of these congruent triangles are also congruent. So corresponding parts of congruent triangles are also congruent. And so you'll see CP-CTC used a lot. Your textbook uses some symbolism that means the same thing. But the phrase I will be using is corresponding parts of congruent triangles, which is the CT, are also congruent. Now because of that, we can now say that we have parallel lines because all the interior angles are congruent. So we continue down, we can say that these lines are parallel because all the interior angles are congruent. And we can say these are also parallel for the same reason. The all interior angles are congruent. Now, once all interior angles are congruent, it's true. When that's true, then we know we have parallel lines. Now, from here, if we take these two pieces of information and combine them to make one last statement, what can we say about the rhombus using these two pieces of information, and that is now true, but is not in the definition? So think about it. Fill in the loop here and out here. Put the reason why you're saying that, and when you're done, turn the video back on. So hopefully you decided that PQRS is a parallelogram. because we now have two sets of parallel sides, and that is actually enough information to be able to say we have a parallelogram by the definition of a parallelogram, which states it's a quadrilateral with two sets of parallel sides. So we can use a definition to say something that is helpful in trying to prove something, such as starting off by saying we have a rhombus, so therefore we have congruent sides. Or we can use information in the definition to be able to say that the shape we're looking at is this special shape. In this case here, we have a parallelogram because we have two sets of parallel sides. So the second problem in lesson 722, they're asking you to start with parallel lines and actually only define one set. And we're trying to use that one set of parallel sides to be able to prove we have congruent triangles. So we're doing something about diagonals. And so we're going to try to prove here is some things that we believe are true about diagonals. And one of the nice things about proof is that quite often we'll start off doing a proof, we'll start off believing something's true, only to find out in the end that we were wrong. Or in this case, maybe you get the right ideas and we're able to prove your ideas to be true. So think about the two diagonals and how they're intersecting each other and what you believe is true. Turn the video back on when you're ready to continue. So the two triangles we're going to focus in on are the purple triangle and the shaded triangle. And we are told that we do have parallel sides, and that anytime we have parallel sides, that's helpful. So that's what these two loops are for. And then we have a third loop here that is going to be also helpful. And then what we're trying to do here is we're trying to prove these two triangles here are actually congruent. So the shape itself is a rhombus, and we're starting off with the fact that we have a set of parallel sides. And so can we prove, based on the information, can we prove that the triangles really are congruent? So draw the diagram, the flowchart diagram, and then fill in the information. And when you're done with your proof, turn the video back on.
So because of the parallel sides, hopefully you indicated that we have two pairs of alternate interior angles that are congruent. Now I used the letter T, you may have used the letters S and R and went the entire diagonal, and that's okay. And because we have a rhombus, then that means these two sides, PQ and SR, have to be equal to each other by the definition of a rhombus. And this is now enough information to be able to say the triangles are congruent by angle side angle. Because of time on the video, I'm going to go ahead and leave you put the letters in the right order for the congruence of triangle loop.
So from here, we're going to actually finish off with the CP-CTC. So corresponding parts are congruent, triangles are congruent. So what can we say about the diagonals that by proving the triangle is congruent is now true? So when you think you have the right answer, turn the video back on and we'll finish up this proof. So this is basically a rotation. This purple triangle, if I rotate it around, so that means that this segment and this segment, PT and TR, are equal, and ST and TQ would also be equal. And so what we've proven here is by proving these triangles congruent, we've proven that PR cuts SQ in half and SQ cuts PR in half. So down here we're going to say that PT is equal to TR, and ST is equal to TQ.